5 days is the total time remaining until the interstellar comet 3I Atlas makes its closest approach to Earth, after which it will disappear forever into the vastness of space. However, in the past 48 hours, 3 of the planet's most powerful telescopes have uncovered a finding that radically alters our comprehension of this cosmic traveler. On December 12, the Gemini North Observatory in Hawaii shared images that revealed a stunning change. 3 Atlas, the interstellar comet we've been monitoring since its discovery in July, now radiates a distinctive green hue. If you happened to witness Comet Hale-Bopp in 1997 or McNaught in 2007, this green glow might ring a bell. But with 3 Atlas, it signifies something significant. We are finally witnessing the true composition of a comet from a different solar system, and the green is just the beginning of the tale. This glowing green color results from a molecule known as diatomic carbon, C2, composed of 2 carbon atoms that bond closely together and fluoresce in a characteristic green spectral region when activated by sunlight. You might counter that this is not new, since many comets exhibit a green glow, and you'd be correct. But here's the crucial detail. 3 Atlas did not display this for several months. From July until October, as the comet neared the Sun, it exhibited a noticeably reddish tint. The spectra suggested the presence of dust and oxidized materials, representing the ancient original crust of an object that had wandered through interstellar space for billions of years. However, in late October, 3I Atlas passed its perihelion, the closest point to the Sun along its path. It came within 210 million km of our star, just interior to Mars's orbit. And at that moment, something intriguing occurred. The intense solar radiation penetrated deeper into the comet's nucleus than ever before. Ice that had been frozen since its formation in another solar system began to sublimate, and along with the ice, molecules escaped, revealing the true chemical makeup of 3 Atlas. The green glow is merely one aspect of a much larger puzzle that astronomers are piecing together in real time. On December 3rd, the European Space Agency directed its XMM Newton X-ray telescope towards 3 Atlas for a continuous 20 hours. What they observed was astounding. When you envision comets, you likely think of visible light, the bright coma, and the splendid tail. But X-rays, that's unusual. Here's what transpires. As 3 Atlas hurtles through space, it continuously emits gas and dust, forming the visible coma. This material collides with the solar wind, the relentless stream of charged particles expelled by our Sun. During these collisions, a phenomenon referred to as charge exchange occurs. High-energy ions from the solar wind strip electrons from the comet's molecules, and when these electrons return to lower energy levels, they produce X-rays. What makes this valuable? X-ray observations can detect molecules that are nearly invisible to optical telescopes. Specifically, molecular hydrogen H2 and molecular nitrogen N2. Both are essential to understanding how comets form and what they can reveal about their home systems. The analysis of this X-ray data is still in progress, but initial findings suggest that 3 Atlas indeed contains significant amounts of volatile compounds, far exceeding what its extensive journey through interstellar space would imply. Then, there are the ice volcanoes. In a recently released preprint, researchers discuss spiral-shaped jets emanating from 3 ice slabs. Unlike the typical diffuse gas plumes we recognize from comets, these are structured, directed ejections. Their interpretation suggests cryovolcanism, or ice volcanoes. Here's the scenario being proposed. Within 3 Atlas lie pockets of solid carbon dioxide, or dry ice. As solar radiation warms the comet, this CO2 reaches its sublimation point and transitions directly from solid to gas. This sudden increase in pressure could mobilize fluids inside the comet, interacting with metallic grains, such as iron, nickel, and sulfides, primitive materials that have been encased since the comet's formation. These chemical reactions release additional energy, driving further outgassing and creating a self-reinforcing cycle. The outcome is jets that erupt from the surface like small volcanic explosions. To validate this theory, researchers compared the spectroscopic data from 3 Atlas with primitive meteorites from Antarctica, known as carbonaceous chondrites. The correlation is indeed striking. This indicates that 3 Atlas shares similar primordial material with the oldest objects in our own solar system, with one key distinction: it was formed elsewhere, likely under different conditions in another star system. But perhaps the most captivating discovery involves the essential building blocks of life. The Atacama Large Millimeter Array ALMA in Chile, one of the most advanced radio telescopes globally, has detected substantial amounts of 2 molecules in the coma of 3 Atlas, methanol and hydrogen cyanide. For chemists, these are not ordinary molecules. They are precursors, foundational components from which complex organic compounds can arise, compounds that are vital for life as we know it. Methanol, CH3, is the simplest form of alcohol, which can react under the appropriate conditions to yield formaldehyde and other molecules significant to prebiotic chemistry. Hydrogen cyanide, HCN, is even more intriguing. It plays a crucial role in synthesizing amino acids, the building blocks of proteins, and nucleotides, the building blocks of DNA. This presents a fascinating question. If interstellar comets like 3 Atlas transport these molecules into other star systems, could they disseminate life? Not as bacteria or microbes, but as chemical building blocks, essentially a cosmic cookbook. This is the old panspermia hypothesis re-examined through the lens of interstellar objects. On December 19th, in less than 5 days, 3 Atlas will reach its closest approach to Earth, at a distance of 270 million kilometers. By astronomical standards, that's quite close. Close enough for Hubble, JWST, and all our best instruments to capture every minute detail. After that, it will move past Jupiter in March 2026, traversing beyond the Oort cloud and retreating back into the expanses of interstellar space, where its green glow will fade. The jets will quiet, and in a few thousand years, 3 Atlas will once again become just a cold, dark rock drifting silently among the stars. But for us, in this moment, it serves as a window, a glimpse into the chemical richness of the cosmos, a messenger from an alien solar system, revealing that within the galactic night, worlds exist whose materials we can encounter, if only for a fleeting, invaluable moment. The green glow of 3 Atlas transcends being merely a beautiful spectrum. It represents the light of knowledge, radiating brightly across the vast gaps of time and space.